Raman spectroscopy is a powerful technique for identifying drugs of abuse. Situated here, our Raman X3, integrated with a Leica DM2700 microscope, gives us microscopic capabilities for Raman spectroscopy. So we can detect and identify drug particles down to the few microns, all the way up to kilogram level quantities. Raman is particularly powerful because it is able to identify drugs of abuse by comparing unknown spectra to a database of certified reference materials. It is also highly selective and sensitive, and it is able to distinguish between different isomeric forms of the same drug, and is also able to identify the different salt forms that the drug may be encountered. Our Foram X3 comprises 3 different wavelengths: 785 in the infrared, 638 in the red, and 532 nanometers in the green. For drugs work, typically 785 in the infrared is favored, as it is able to suppress fluorescence effects of either the drugs themselves or cutting agents and contaminants within the drug mixture. So Raman, as a non-destructive, non-contact technique, can be suited for trace evidence analysis, and trace drugs falls into that category. So here we have a set of scales, fairly commonly encountered in drug scenarios, and on the scales there is some drug residue. So in order to sort of analyze this in situ without having the need to swab and potentially destroy or damage fingerprint information, we can place the scales into the sample area. I'm just going to change the objective to a 20 times objective, which gives me a sampling area of about 5 microns. It's a surface technique primarily, so we're just going to focus onto the surface of our scales. And we're just going to target some of that material that we can see. Make sure that's in focus. Set our acquisition parameters. The system in auto exposure will automatically set the scan time so that it fills the dynamic range of the detector, and so that the system is always operating at its most sensitive. And then we'll click scan. So because we only have a thin layer of material, and also depending on how Raman active that material is, the system will then determine the optimal scan time, which is now gone to 50 seconds. So after 50 seconds we'll have a spectrum of the material that is on the scales. Okay, so from trace residues on weighing scales to trace residues of powders in bags. Now there's not much powder in here, and we can actually analyze this through the packaging. So just place that on the sample stage here, and then we'll just use the microscope controls to magnify into the packaging. And there should become a point where we can see the surface of the bag, and then if we keep focusing through, we should be able to see some particles through the packaging that we can then focus our Raman spectrometer on. Okay, so we can see some crystalline material through the packaging. Got our crosshairs targeted on there using the 20 times objective, giving us a 5 micron sampling area. And we can use the same process as before, so we set the number of average scans, and we select auto exposure so that the system will automatically determine the best exposure time for this particular sample. Give our spectrum a title, click scan, and away we go. So scan time for this sample, 45 seconds, and because we set 3 counts, it will do 3 times 45 seconds. So quick analysis time, and we're able to perform this in situ within the plastic bag itself. This may be especially important for some drugs that are highly potent at sort of low levels, drugs such as fentanyl, some of the psychedelic phenethylamines, where minimizing exposure to the examiner would be highly beneficial. So from trace powder in plastic bags to larger quantities of powder, in that case we can sort of decant a small amount of the contents into a silver dish or some sort of silver foil container, and then we can just analyze that directly under the microscope. Again, given the small sampling area, homogenizing the sample might be beneficial, or even to sort of reviewing whether there's any sort of different mixtures of materials in there. You could essentially crystal pick at this level of magnification. So we'll just again get the sample in focus so that we can clearly see the crystalline or powder material that's in our sample, and then we'll just get the crosshairs onto a part of that and get that in focus. Give our spectrum a title, so unknown white powder. Set number of average scans, and we'll hit record.